If space and time measurements are all relative, is there anything that stays the same? Physics penguin, that is such a great question. There is so much in physics that is all about figuring out where and when things or events happen. And in everyday life, that's usually no problem. We can toss a ball, and based on how we throw the ball, we can calculate where and when the ball will land. But all of a sudden, if we start to do things like launch a rocket towards another planet or look at distant stars and galaxies and start asking these questions of where and when these events happen, where will our rocket land? Hopefully on the planet we aim for. Um, it starts to get a little weird when you are at or approaching the speed of light. So, how do we actually figure out where and when things are happening when we're dealing with relativity? Well, there is a special quantity called the space-time interval. Ooh, fancy. But really what it means is that it is a quantity that everybody can agree on. Regardless of whether or not you have an alien friend 45 light years away, you would be able to agree on the space-time interval of two events happening. So it's basically a special ruler for helping us measure where and when, well, the distance, I should say, in quotes, because it's both space and time distance, that two events happen. Okay, so what is that equation? The space-time interval is defined as S, and the space-time interval is equal to, I'm going to use a bunch of different colors here because I love colors. It is equal to C times the time interval squared. We'll pull yellow back, minus, la 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 la, let's use green, because the earth is lots of green. Minus, I'm gonna just be lazy here, delta x squared. So this is the interval, the space interval. There would really be kind of three parts here, so you could have, because space is in three dimensions. Ha! Look at that. So delta x plus delta y, oops, it would be squared, plus delta z squared. Like that. And let me just double check. Yep, that's it. Okay, so this quantity right here is our space-time interval. That is the thing, the quantity, the number that we all can agree on when we're measuring the distance of events that are in relativity terms. So things that are moving very, very fast. This is the time interval, or the separation in time. And we have our conversion factor C to help us get the right units, and also because that happens to be the proportionality constant, because the universe is interesting and we are not here to tell the universe what to do. We are here to figure out what is happening. And then this is the separation in space. So there are three different kind of buckets that our space-time interval can be in. So delta S can be less than 0, because look, we have a little minus sign over there. So if the separation in space is greater than the separation in time, then we will have delta S less than 0. And these are called, hold on, let me again check my notes. These are called space-like. Delta S can also be greater than 0. And what do you think? When does that happen? And what do you think it might be called? Yeah, totally. These are time-like intervals. And then you also have this rare situation where delta S could be equal to 0. So if the separation in time equals the separation in space, you get an interval of 0. And events that fall in this category are called light-like. There we go. All right. So if you're curious about what these three categories mean, we can dig into that. So maybe you can chat with Physics Penguin and get some questions queued up about relativity, and then we can dig into those. But also, of course, if there are other topics that you would like to learn about, please just let me or our little puppet friends know, and we will learn all the things science, tech, engineering, math, because this universe is big and beautiful, and it is a just wonderful, magnificent miracle that we are here to observe and poke at some of these magical mysteries around us. All right, thank you very much for joining, and we'll see you next time. Bye.